Hey everyone, this is Dr. Perlman. I'm in the Inorganic lab, and we are going to, or I am going to, and you are going to watch me, do the second part of the lab that we did right before spring break. So as you'll recall, right before spring break, we made a cobalt pentamine carbonate complex. It was the purplish reddish solution. And today I'm going to do the second part of this. This is in your lab manual that I'd like you to follow along. It's in the lab manual on page 137. It's the top paragraph. We're going to substitute that carbonate for a chloride. And yeah, hope this works. All right, here we go. So in the fume hood, I have about half of one of the solutions from last time. I think I'm using Delaney and Cabes. So as you'll recall, last time we had some trouble getting this to precipitate, and I just had you leave them under watch glasses, and they look much the same as they did before. They were forming just a little layer of crystals on the top that were kind of reddish purplish, but I went ahead and redissolved them, and I took about half, which should give us about the right amount of solution for this next part. So basically, instead of dissolving the precipitated crystals, I've just taken half of the solution you had before that didn't contain any precipitate. And so that's that solution, all right? So now the first step is that we're gonna, I'm gonna go ahead and put it on the hot plate because we're gonna stir this here in a moment. I'm gonna get the stir bar going, and we're gonna have to heat it here in a moment anyway. All right, nice gentle stir, and then we're gonna add, the procedure calls for about 5 to 10 mils of hydrochloric acid. The point of this is that we're gonna try to convert that, we're gonna try to replace that carbonate that is currently attached to the cobalt with a chloride. If we do that in acidic solution, we get a chloride instead of a water. All right, so you see the bubbling going on? Down here, this is just from the hydrochloric acid hitting the water. But those bubbles are the carbonate getting converted to CO2 gas. I'm actually going to add a little more. One of the things I was never convinced of last time is that we actually got all of our carbonate, ammonium carbonate, out of there. So I'm going to just drizzle in just a little bit more here and see if it stops bubbling. Oh, no, still more bubbles. So I think we've got excess carbonate in there, ammonium carbonate. So we're going to try to eliminate that by adding a little extra carbon dioxide here. A little extra HCl, which is expelling carbon dioxide. That's still quite a bit going on. We're going to let this stir for a minute and get all the rest of the dissolved CO2 out of here. Add a little water to get some of this solution that's gone up onto the sides back in there. There we go. And we're going to let this stir for a few minutes and get the rest of that carbonation out. At this point, we basically have, cobalt 3+, ammonium, cherry soda. Just don't drink it. All right. We're gonna let this go for a little bit. All right, folks, we're back. It's been about 5 minutes since I shut off the video. I've gone ahead and hooked up a pH meter. And our pH, we're about 3.5, so we're good and acidic. All the CO2 has been pushed out of the solution, or at least I hope so. And so now we're going to add some ammonia to bring this guy back to neutral, and then a little more basic, a little beyond that. So we're going to add some ammonia. This is concentrated ammonia. And we're just going to keep an eye on the pH over here till we get to around 7. Oh, a little past. So we're going to add 4 or 5 milliliters beyond that to make sure there's plenty of NH3s in our solution. Okay. So that's going to mop up, we're going to get to neutral to mop up the extra H pluses floating around, and then add some ammonia to make sure that we've got plenty of amines floating around in our solution. All right, now we're going to heat up for a little while. Now's the boring part. So we're going to heat this guy. I'm going to keep an eye on it and hopefully be back in about 20 minutes. All right, so I have heated the solution to 85 to 90 degrees C for about 20 minutes, and I've let it cool down a little bit. And so we're going to add the hydrochloric acid now. So we got 75 mils of con HCl, and I'm going to take my thermometer out, add that HCl. This guy back up for about 20 minutes. All right, we're about halfway through the heating cycle. For this time, we're finally up to 90 Celsius, and there's a distinct change in color at this point. Whereas earlier we had more of a rose color, this is more of a purple color. How well that shows up in the video, I'm not sure, but there's a distinct color change at this point. Here in a few minutes, we'll take one more look at it again before we take some UV vis data. All right, so I heated the solution for another 30 minutes and then began to cool it, and I turned off the stir bar and got this interesting color separation. I hope you can see this in the video. This upper layer here is green, and the lower layer where the precipitate is forming is that rosy purple color that we were seeing earlier. And I think what's happening here, although I'm gonna pull some papers that I'm gonna make you guys read, I had been reading, I think we messed up, but in a cool way. I had been reading earlier that if you don't add enough hydrochloric acid, or if you do it slowly, or don't add con HCl, that you can get the dichloro tetraamino cobalt complex, so 4 amines and 2 chlorides. So we were supposed to get 1 chloride in there. I think that maybe because we started out with a higher solution volume initially, maybe that we've actually gotten the dichloro. The dichloro has two isomers, a trans and a cis, and I don't remember which one's which at the moment. I'll go home and look at it and put the information up on D2L, but I think that's what we've accidentally done here. So that's kind of fun and exciting. It's, you know, screwing up is okay in science, especially when you get cool and weird colors. So anyway, I'll post some more information. I'll get you guys some UV vises, and we'll go from there. Thank you.